going on, boys? Welcome, welcome back to another video. Yeah, let's just get that bird done before going. Yeah. All right, so this is literally all I've been doing for the last, I don't know, couple months now. Just kind of sitting here, tapping away at the keyboard, making progress on a project called Ex Nihilo, which means from nothing. And I'll show you why it's called from nothing in a little second. So for those of you who don't know, I've been working on a bit of a pixel simulation project over, I don't know, let's see how long I've been working on this bad boy for. So it clocked in at exactly 50 hours, which is, I could have done that better if I tried. So that's 50 hours of total just kind of like deep work, fired in, focused, getting stuff done. Anywho, this is the result of that. It's pretty much just pixel simulation. Nothing really too fancy here. Holy shit. Look at those frames. What the fuck? Needs a little bit of optimization, alright? It's probably just because I'm recording. Okay, it turns out I was using the wrong encoder, so this should be a whole lot better. There we go. It's still not perfect, but it gets the job done. So yeah, Pixel Sim. You may recognize this from, I don't know, like a couple of years ago I touched on Pixel Sim. And really all this project was an attempt to wash the Unity taste out of my mouth after I tried making a game in Unity and just failed miserably because I did not enjoy using the tools at all. So that was like towards the start of the year. I'd say probably I did that in like the third or fourth month. January, February, March or April, yeah. So then I was like, all right, well, what can I do that isn't making games in Unity? Because, all right, so bit of a step back. My whole reason behind wanting to do that in the first place is like, all right, well, I've got to start shipping some actual games. I've got to make some games, get them out quickly, get them done, ship them, go. So then I was like, all right, well, why don't I use Unity for that? Because it'll be really fast. I'll get to practice game design, all that kind of stuff. I tried that and tried to decouple the whole programming side of things from the whole game design side of things. I was like, well, if I just focus on game design, then I can get good at that and just completely ignore about the program. Just like write dog shit code. How do I write dog shit code? Oh, I can use Unity. Bada bing, bada boom. So that's what I tried. And then realized that game design and programming are they can't be that decoupled, right? So I just I don't want to say burnt out, but I kind of just got burnt out with using Unity and didn't end up finishing the project. I got close. I got probably over halfway, but couldn't round it out, couldn't ship it. I did actually also make a small game in Unity, which I don't have the build. I did meet up with the guy that I made it the other day in person, and he had a build on his phone, and this was it. My God, that's loud. And yeah, this was the game. It was actually really, really fun. At the end of the day, we made something pretty juicy, pretty polished. It's very simple. Like one input. We made it over, I'd like to say 3 or 4 days, something like that. Initially, it was just like, all right, how can we make a game in a day? And then, it turned into a bit of a weekend project. And then, 3 days, 4 days, blah, blah, blah. But it turned out really good. That wall jumping mechanic is just, I don't know, man. I did the movement control for it, for this. He did most of the like visual kind of polished stuff. And yeah, it turned out pretty solid. We didn't end up rounding it out and completing it. We still had to do a bit more level design. But it's close to being shipped. This close, not quite. So that was really fun. So I did kind of successfully make a game in Unity. And then boop, and there's the game loop right there. Pretty goddamn cool. I did manage to do it, but not quite. So then I was like, all right, well, I want to get back to programming in C and using Telescope and stuff. And my whole reason initially for using Unity was yes, I wanted to write shitty code. But B, Ryan was in the middle of a big telescope overhaul, and the new version wasn't ready yet, and I didn't want to use the old version because then I'd just have to reroute my stuff to the new version, and it just would have been a whole thing. But eventually, hang on, let me plug my laptop in so that we don't run out of charge here. So yeah, and then directly after that, I was like, all right, how do I wash this Unity taste out of my mouth? And I basically just stepped down and learned D3, D11, DirectX, and just wrote a small kind of like, just try to wrap my head around the whole API and just wrote some D3, D11 code and got that up and running. And that was kind of fun. And then beyond that, I was like, all right, what can I kind of do next? And Cherno came out with a series that he's still doing called ray tracing. Just ray tracing from scratch. So I was like, okay, how about I go do some ray tracing, you know? Like, you can't get further from my original, like, let's make games and design them in Unity type beat, you know? But I just wanted to go to the exact opposite end of the spectrum and just do stuff from scratch. So I got a little bit into the ray tracing. I don't know if I have any photos anywhere of that, but I didn't get very far. And then I was like, all right, maybe not ray tracing. I have zero use case for this at all in the future. I'm just doing it because it's something to do. And if you think about it, really, there's an infinite amount of things you could be doing, an infinite amount of problems you could be solving. And it's like, why not pick the ones that will actually benefit you long term? Ray tracing wasn't one of those. So I was like, okay, a couple weeks in, I was like, let's do something better. What can I do that's still at this kind of like low level, low end, that's still going to benefit me long term? That's still going to be something that I will be using long term. Sounds like pixel simulation. So then that was the whole reason for this project. Went down this kind of like whole 2 months kind of fiasco of getting this up and running. At the end of the day, I only put about 50 hours in, which over 2 months is not a lot. And the majority of that was actually towards like the last week. I put in probably like 20 hours over this last week or two. The majority of it. I'd say probably like 30. So yeah. And yeah, this was the result of the entire thing. I wonder if I can full screen. I can full screen. That's nice. It's a bit slow though. It's just let's do it down here. Not the best in terms of optimization. I did actually do a optimization the other day, which made it amazing. But I think I broke it with some recent stuff. That's okay though. That is okay. So yeah, this is pretty much it. I just recently did Fire, so that spreads up and it's kind of nice. At the end of the day, there's still a lot more I could be doing in here that isn't this. Like there's a lot more polish that I could be doing. But I was kind of like, all right, we're coming up on the deadline. I want to finish this, have it over and done with, tie it off, and move on to actually making games, which we'll talk about in a little bit. But this video is really just going to be me going over the entire tech for this, what went into it, me explaining some of the kind of hurdles that I had to cross over, and yeah, just how I did all of this. So we're just going to dive into it. I have no idea how long that's going to be, probably like an hour or so, at least. And yeah, so this right here actually isn't the full picture. This is only a sandbox mode, if you will. Now, it would be funny if this just broke, but I haven't tested it in a while. So that's just my sandbox pixel testing mode for me to actually, I just finished up with a Fire logic and doing some stuff. But the whole purpose of this entire project, ex nihilo, right? Yep, we have a build error. All right, let me fix this up real quick. What are we doing? Oh, we're debugging chunk rewards. State unclad identifier, of course, it'll be something like ex state. Yep, there we go. Oh, what is this? What is this you see? hang on a minute. Is this an infinite world? Oh my god. So, now you'll notice, to begin with, actually that's a bad example. What's my airbrush? There we go. You'll notice, just like normal, if we were to place something, like some sand, it'll just fall off the screen and disappear into the void. Where did it go? So if we're trying to build an entire pixel simulated world from nothing, that's where the X nihilo comes in. Then we're going to need a little bit more than that. So right now, there's no UI whatsoever because Ryan's still working on the UI module. So I have about just my entire keyboard just mapped with key bindings. If we look at this over here, this is me just doing a bunch of if statements for a bunch of key bindings. But that's okay. Gets the job done. So if we freeze the world simulation, and we actually go ahead and make a nice little island here, right? This is a from nothing, and we unfreeze it. Look at that. We now have a foundation to build our entire world out of, right? And then we can go ahead and actually just place some stuff down here. And you'll notice, look at that right there. Isn't that goddamn awesome? That is structural integrity coming into play. Oh, that's water. That's not what I want. The keybinds can be a little bit tricky sometimes. But yeah, that is structural integrity right there. It's not perfect. It just frays away at the edges, which is kind of cool. And you can change the modifiers depending on what kind of type it is. For example, dirt would be a lot less rigid. Stone would be even less so. And yeah, that's pretty goddamn cool. So I did actually set out to do the whole purpose of this project, X nihilo, to make worlds from nothing. I set out to do it, and I actually did it. So that's always lovely. So yeah, there we go. Now the water's a little bit buggy at the moment, but if you just ignore that, that's completely fine. And if we actually go off screen and come back in, then you'll notice, wow, serialization. It's actually completely serialized. And that is, where are we? I'm going to go over this entire structure in a little bit, but I'm just demoing the entire thing at the moment. I think this is really cool. So if we go to the build, have a nice folder called balls, and that serializes all of the chunks. And yeah, bada bing, bada boom. So this is actually stuff that I've done in the past pretty much, and it wasn't a lot of real busy work, because I kind of have done pixel sim in the past, and I've done chunks in the past, and I was just kind of merging those two together, and it was easy enough. So I feel like that's pretty much the entire project. That's all I kind of have in at the moment. Yeah, we got the fire there, which is pretty cool. Yeah, that's it really, and it's pretty goddamn stable. So that's always a plus. So yeah, anywho, coming up on the deadline for it, and the reason it is deadline is because in less than 24 hours, I am hopping on a plane and flying to the other side of the world. And I just wanted to have this wrapped up before then. Right now, I'm in Australia, and it's kind of chill. But yeah, I'm headed off to my next location in tomorrow morning, so that's going to be a lot of fun. And I managed to wrap it up just in time. Anywho, let's dive into a bit of the tech and the whole structure of this project. That was kind of like the demo for it. So let's dive into how this bad boy actually works, how it runs, how it compiles, all that kind of juicy stuff. I want to see if I'm forgetting anything with the rough kind of overview. That's probably it. How initially came to be, yeah. Yeah, pretty cool. Alrighty. So, very recently, over the last few days, I have just set up this kind of environment. You'll notice I'm using Visual Studio. No longer using 4Coder. Rest in peace, 4Coder. It would be hilarious if none of this worked and this entire recording was bust. That would be so hilarious. So funny, bro. Yeah, so My reasoning behind switching to Visual Studio is because it's just so much easier to set breakpoints right here and just be able to do that, and it hit the breakpoint and you just easily be able to debug stuff. Like that's literally the whole reason, because I don't want to tab out full coder, boot open Visual Studio, then debug or remedy BG. I'm actually going to unpin you now. Goodbye, sir. I'm sorry. Yeah, so True New and integrated development environment is kind of really good for when you're working long term on projects like these. Not me. Yeah, so that's why I'm using Visual Studio. It's just easier and better all around. Anywho, let's kind of go over the structure that I've got right in here. So we have an entire solution called the mountain. That's this bad boy right here. And we've got a couple things in here. Template, which is just kind of like a template that I can copy and paste for making new projects. And we have the forge, which is what I'm currently building and running X and Hilo through. Now the idea of the forge is kind of just to be like a scratch of like, we're just kind of fucking throwing shit in, getting stuff to work. And it's my build environment for getting projects up and running, getting tech up and running, all that kind of stuff. And then at some point, for example, X and Hilo, if I were to actually package this up and ship it into a standalone thing for you to download and use, say like a build on Itch or Steam, that's when I would actually like clone template, make X and Hilo, make an entire thing, and do all the release mode and all that kind of stuff. But for now, it's just staying in the Forge, and I've extracted it out into its own kind of little folder, which is nice. It's nice and neatly tucked away for me to come back in the future and just, take that off. So how the Forge works is, I guess we'll start over here with the forge.c. It's literally just these three bad boys. You've got enter, exit, and update. And these are run by the Telescope backend, which we can look through over here. And yeah, this is literally just Telescope. It just has an entry point, and it's a Telescope functions, and it just calls into enter, exit, and update. And that's pretty much it. There's obviously an entire massive underlying system of Telescope, but we're not going to dive too much into that because, you could literally swap this out for any kind of framework or engine, library, whatever you want to call it, and it'll work just the same. You just have to go in and change all the Telescope specific stuff, like the types, the textures, like the rendering, all that kind of stuff. But it wouldn't be too hard at all. Anyway, so we've got the Forge, and you'll notice that X and Hilo is very, very neatly segmented off into its own .h and .c file. And this is ex enter, enters into X and Hilo, exits X and Hilo, and updates X and Hilo. So that one's pretty good. And we can just go in here to the update. And this runs every single frame, and is just the entire application. So that's pretty cool. Forge over here, we've just got some state, and then this is the X and Hilo state as well. So I guess we start with the state, start with all the structures, and work our way down from there. So I've got a nice little comment here for future Randy. That's going to be amazing. This is pretty messy at the moment, as I'm sure you can see, with all these static local variables and just general. This is 1,700 lines of code, but at least it's a compartmentalized piece of mess. So that's always good. Alrighty, so we'll start from the top and work our way down. Now, I think, we'll start off with the meta file. So we'll see these two right here. We've got the generated xandhilo.meta.c and the generated xandhilo.meta.h. And these are generated via Metadesk, which is absolutely amazing. It is, how do I explain this? It's just a meta program that runs before the compilation of this entire thing, right? And it just takes this entire file and spits out generated code. So this gets generated, this is generated from this, and this is also generated from this. So the idea is you have, you can just write metacode on top of C and do some cool stuff that you wouldn't otherwise have to do, that you wouldn't otherwise be able to do within C itself, because this is a lot more flexible. So yeah, that's pretty cool. And we'll just break down this kind of pattern over here. So this is directly from old mate Ryan Flory. I mean, he made Metadisk, absolute champion. And this pattern right here of the table is straight from him, and it is absolutely amazing. I'll leave the link to the blog post where he went over this entire pattern. It's really quite something special. And I think if we probably just close out of this, we'll just maximize it somehow. Here we go. So to begin with, we've got the pixel flags. Now, this is another pattern that I also got from Ryan. And it's basically like, how do I explain this? So typically what you would do, or what I originally was doing, is these are all the pixel types, right? So we've got undefined, void, boundary, air, water, sand, smoke, blah, 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 blah. So for each update, so we'll come down to pixel step. So this gets run each frame for every single pixel, right? For each update, what I used to do was just grab the type and then you do a switch statement on the type. So if the type is water, do this. If it's sand, do this. If it's smoke, do this. But the problem with that is you duplicate a lot of code. And so, because for example, sand, it falls down, it moves down every single frame. Water, it falls down, moves down every single frame, goes left to right, same as sand. Like it's very, very similar. So instead of having a switch statement on the type, you instead extract out the kind of functionality of those types, right? And that's what this pixel flag table is. So we've got, you can move downwards, you can move left to right, move X, move Y, up and down, diagonally as well. Fall and rise. Fall means you're moving downwards, rise means you're moving upwards. So fall is for sand, rise is for smoke. Smoke is literally just sand in reverse, if you really think about it. And then we've got a few more things in here, which are just other functionality, right? And now the way you defined the behavior of sand is there's all these flags over here, which correspond with all these bad boys up here. So they're literally just booleans, and it's like, does it move X? Yes, it does. Does it move Y? Yes, it does. This is a little bit unclear. Like I could expand this out into, say, all of these and space it properly so that these all line up, but it just would have made the table a whole lot bigger. So I probably should have done that for clarity, but you can imagine how this works. So sand has move X, move Y, move diagonally. It falls down. It does not rise up. It does Y to X splat, so it transfers the Y velocity to X velocity when it falls down. That's how it gets this nice little effect of, let's just have a nice thing here. That's how it gets this nice effect of like the piles aren't entirely uniform. Like you can see this pixel out here kind of moved pretty far away when it fell down. We just freeze it. You see the whoosh, it slides out like that. So that's pretty cool. And then, yeah, a bunch of other flags as well, which we don't really need to go into. But yeah, that's pretty much how it defines. And water uses a very similar set of flags. Water is pretty much exactly the same as sand, except for this variable, which I'd imagine is structural integrity. Yep. But we could actually get rid of that, and water would behave exactly like sand. The only difference is in the friction. So water doesn't have any friction, so it continues to move left to right no matter what and find an equilibrium, where sand does actually have some friction and will come to a stop given enough time if it's sliding along the ground. So that's really the only difference there. and the resting integrity as well. So you can kind of imagine how useful it is to break apart the functionality into these flags over here and set the flags instead of switching on the types of the pixel. So that's probably the one thing that I am most excited about in this entire thing, was that kind of realization there. And again, it was thanks to a different article of Ryan's, which I'll also link down in the description. And I'm going to make a list of all the things I talk about, that way I don't forget it. So first things first, we've got the metadesc table pattern, and then we've got the combinatorics thinger with flags. Cool. And I'll dive into the metadesc table pattern a bit more here, which is this entire bad boy. So yeah, it's literally just a table. You've got name, string. This is just for formatting's sake. Like, this is technically just all on one line. It's one big long definition. And so what it does, so this is a table right here. This is how the data gets defined. So name, you've got void or sand or whatever. String, this is the pretty name. So, you know, if you can imagine this being displayed as like a list in a UI, this is the kind of thing we would grab just to make it nice and pretty. It's a string. And then of course we've got all the flags here. And then after that, we've got some more specific data about the acceleration, max speed, start life, friction, the pixel type, spread to, blah, blah, blah. And so that's how all the data gets defined in the table. It's really goddamn lovely. And then what happens is we take this table and we generate some actual C code for this bad boy. So this is the pixel flag generator. So it takes all of the pixel flags up here in the table, which this is just another separate table. And it just makes an enum for all of these bad boys, which we can see over here. Pixel flag enums. So that's just all of those. That corresponds to this piece of code right here that generates the entire thing out. And then pixel type, very similar thing. It grabs all of these names and creates a enum of pixel types. And then down here is where the magic really happens. It's a little bit messy at the moment, but it gets the job done and it's fine. So this literally just creates the structure for all the pixel data. So you'll notice that all of these correspond to all of these parameters. So this is just the structure of it. And then that generates this bad boy right here. It's just a struct of it. And then the next thing after that is we're actually taking all of this data and we're filling it in an array, which gets indexed into based off of the type of pixel it is. So that might be a little bit confusing, but we basically take these types, we take these types and we index into this array based off of these types. So these enums are really just 0, 1, 2, blah, blah, blah. So this 0, 1, 2, and so on. And this is where all the data is actually stored, so we can access all of this data, lovely data in here at runtime and kind of do anything with it. So that's pretty much the whole setup here. And then we've got one last little bit of code. So this is all in the header. And there's one little thing that actually goes into .c, which is does pixel have flag? And it just takes the, all right, does this specific pixel have this specific flag? And it just does a nice little check on that and returns true or false. So yeah, that's pretty much the entire Metadesk thing that I got going on at the moment, and it works pretty goddamn well. So now within the implementation of how we run that each and every frame, pixel step, this gets run for every single pixel. And it's a little bit messy, but it gets the job done. So we see the vertical movement right here. So does this pixel have the move Y flag? And if it does, then it'll just do all that logic. And since it can move more than one pixel across the frame, that's why I've got this kind of sketchy thing going on here. but it does a for loop through each pixel that moves through and does checks of whether or not it can move to the pixel and all that kind of stuff. And it's just logic for the entire pixel sim. If you're curious, I'll have the source code for this entire project down in the description somewhere. It'll probably just be in a .zip file since we don't have the public repository up and running quite yet. It is in there somewhere, but yeah, should be right. Okay. Yeah, so that's pretty much the entire thing, and then that's just a big ass. Instead of it being a switch statement for each of the types, it's literally like, does this pixel have this specific flag for implementation, right? Does this have the move Y flag, right? If it does, move Y. Does this have the move diagonal flag? If it does, try and move diagonally. Same thing for, what is this? Move X. Move X, so on and so forth, right? Apply friction. If it has any friction, this friction is basically just right here, right? So yeah, it just does logic for all of this kind of stuff. And that's pretty cool. Again, messy as shit, but hey, that's why I've got this this nice little welcome message for future Randy. So yeah, that's pretty much the entire project. Oh, all right, so that's the low level of how the pixel sim works. Now on the high level of the chunks, so yeah, that's all the pixel data and pixel types. That's how they get generated. This is the actual structure of the pixels. Now, ideally, I'd only have type and some other data, which would be all of this kind of like packed into something really small to keep it nice and lightweight. But right now it's just one big steaming dump, which is, you know, pretty unoptimized, but who the fuck cares about optimization when you're just trying to get something to work? So this is the chunk right here. So each chunk, right? And in the exit state, so this is state that just gets allocated right at the start of the application, and you get it application wide and you can just use it. It's just a global. Gets the job done, right? So you have a chunk, you have an array of chunks, which has a maximum amount of active chunks, which is 78. I got that number from just doing some performance profiling, and yeah, this is probably like the max amount I could really do. I mean, I could definitely like focus in on this and get it even bigger, but it's like, why make things bigger if you don't need to make things bigger? Like, how fucking slow that is, dude. But yeah. So yeah, that's 78. Like at the max camera zoom out here, you can have like 78 chunks visible at one given time. And then each of these chunks has, these are just whether or not the chunk's valid or initialized, or whether it's has a position. And this bad boy is where all the pixel data gets encoded. So we've got pixel, and then it's a double array. So we've got chunk size. So it's a 64 by 64, which turns out to be, I'm not good at math, 4096 pixels in any given chunk, right? And these just get indexed. So this is the Y, this is the X. Let's see if I can find an example of like accessing an absolute value in here somewhere. I'm sure we can do like relative value. Yeah. So the left. So again, the pixel to the left of this pixel, that's in the thing. Pixel at relative offset, and we just go like -1 to the left, right? And then that is actually just shorthand for doing some weird magic stuff in here, and it gets the absolute, this is really inefficient, but it gets the job done, right? Absolute position of this, and it basically just indexes directly into the chunk, right? X index, Y index, which indexes directly into here. So we've got the Y, we've got the X, Y, X, right? We've got a nice little assert here because I didn't have an assert here a while ago and I was getting a really annoying bug that I just could not find. And it turns out I was classic C move, accessing a out of bounds, indexing into a out of bounds array, which is lovely. That I didn't get an error message for that, but welcome to C. Alrighty. So yeah, that's pretty much the kind of high level data structure, right? And then this is just the texture. So literally every single frame, it just takes all of these pixels, does a switch statement on the pixels. Let me see if I can find this bad boy. I don't have a good way of navigating in Visual Studio yet. I haven't figured that out. But if we do like render, it'll be in here. Chunk render, here we go. So yeah, it just loops through 64 by 64. This is the bottleneck for performance at the moment. So yeah, it just goes through here and does a switch statement on the type of pixel and then gives a different color. So stone, air, sand, water, wood, blah blah blah, and it puts the RGBA values right in there. And 255, that's, yeah, it gets the job done. We got some tinting stuff happening, some pixel selection, and some other weird rendering stuff with the smoke. Ideally, I'd make another system outside of this, which would kind of like segment out the idea of rendering. But I can't be fucked. I'll probably do that when I come back to this project in like 2 years' time. But yeah, that is how the entire thing gets rendered. Whee! And there's just a nice little fade on the smoke, which is what this thing is doing here. Yeah, so that's pretty much the rendering. And that's pretty much the entire project, you know. It's pretty simple at the end of the day. Yeah, very messy, but problem for future Randy. At least this is segmented off and not tightly coupled with Telescope to the point where I'll just rewrite this again, right? I'll literally just come in here and update it and clean stuff up and optimize it in the future. My entire goal for creating this project to begin with was so I could have a tool for building out pixel simulated worlds from scratch, just like this. And I did it. It didn't exactly turn out the way I was intending it to from the beginning, but that's just because I didn't have any UI. I didn't really polish it that well, but I did get this core functionality right here, which that's all I really cared about at the end of the day. And yeah, that's the entire project, I guess. That's the whole breakdown. Now, you guys did have some nice little questions on Twitter as well, which I will go over now. Alrighty, so I'm just going to go through a bunch of these, and yeah, I feel like I've answered a decent amount, but we'll figure something out. Simulations take a relatively quick time to reach a local equilibrium. Through lies in deceit, yeah, but if you were to actually truly simulate something like this 24/7, it would instantly just devolve into chaos, which is, yeah, like this right here. The whole reason this is happening is because these pixels aren't being updated. So also this water, I need to figure out a way of like it figuring out when it's level, because right now I just do a really scuffed thing where it's like after a certain amount of time we're going to stop doing the fast update and just kind of have it float around like this. So yeah, there's a lot of stuff that I can do in here to a lot of like micro level logic stuff that I need to do before this actually is kind of inside a game that's playable on a macro level, doing something else. But this entire project is really just like the base foundation of like a game where you would build out an entire world. You would have like, my initial idea was you have like a nice toolbar in here, and it gives you brushes that you can paint with, and like different tools for actually creating terrain and all that kind of stuff. Which I didn't get around to doing, but that's just because there's no UI in Telescope at the moment. Yeah, so eventually this will be a tool for building out worlds. It's not really at the moment. It's more of just like, hey, look at this cool little pixel simulaty thing. But yeah, eventually it'll be used in some high-level kind of game projects, which probably doesn't answer the question, but good enough. Alrighty, we want to go ahead and create a simple project of my own. I'll love this in-depth, blah, 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 blah. Yeah, that's certainly a question, but amen, brother. So I'll actually give you some resources for what I followed for this. I will leave this down in the description. If you go into this is like an old document that I was using to map out tasks. It eventually got a bit chaotic, so I just moved it all to Trello. And then that's the entire thing here, and I did actually manage to wrap it up. Yeah, so there's like a bunch of like other stuff that I can be doing, but it's all just minor stuff, and I wrapped it up nicely into its own little module, so project equals success in my eyes. So if you come down into the examples down here, yeah, I'm just going to link this entire document in the description, and you'll be able to dive into all those bad boys. But the main ones that were really, really helpful were this one right here of the dude implementing the falling sand sim himself. Like this is just absolute wisdom nuggets in here. Doesn't like dive in depth into the explanations, but gives you a nice high level overview of how the logic should work and all that kind of stuff. Especially his way of enhancing the solids. I really, really enjoyed this. I didn't get around to actually doing this specific thing. I almost did it, but yeah, job for another day. I did do the this thing that I was showcasing before, with like the splatting down, and it all spread out. So that's really cool. So that was that, and Sandspiel, there isn't any implementations in there really. And this guy right here, Jason.today, absolute legend. This is ideally what it will be looking like eventually with enough polish. I just couldn't really be bothered doing the polish. And you'll notice this is a really nice pyramid here. We can avoid that with the current tech that I have in at the moment. So it was really, I took a bunch of different examples and took the best parts of all of them and kind of like merged them together. Didn't quite get there, but yeah, this is a really good example of fire. And this is how I got the idea for the fire spreading and all that kind of stuff, and the smoke. So this was a really good resource. Yeah, you can go back to the very first one, Falling Sand Sim. The code is very, I think it's in, I don't even know what this is. It's like Rust or some shit. I don't know, but it's web something, and it's a little bit icky to wrap your head around, but you know, it fucking works. He has nice overviews of what's going on. And yeah, so that's pretty cool. There's all the examples you need to get started, and yeah, your hand. It's a lot of fun. And of course, I'll have the source code down in the description for the stuff. What was an unexpected hurdle, and how did you overcome it? The whole thing was one big unexpected hurdle, right? I can do this, but what's the cost of me to go do that? So for example, I had an idea of like, all right, instead of making it, let's make the entire thing run parallel on the GPU, you know? Like, shit. Oh, I thought that was a bad red right there. Never mind, we're good. So I was like, I could figure that out, but it would also take me months to figure out. So it's like opportunity cost of like, all right, let's just move that off to the side. I don't need it. Same thing with Fluid Sim. I was like, yo, let's Navier-Stokes round 2, baby. Let's do a really cutting edge fluid simulation, right? But I just did the falling sand one, made it look good enough. I was like, all right, let's just move on. So it was really about, that was the hurdle of like realizing what I can do in what amount of time and just kind of like doing the bare minimum to make it look good and possible, and then just moving on, right? So that was pretty goddamn cool that I actually managed to get this to where it is today. And it's not like, I'm not diving down into 6 months of trying to do Navier-Stokes fluid simulation parallelized on the GPU, which I could do, but at the end of the day, there are a million problems out there. Solve the ones that'll actually move the needle and advance what you want to do. So yeah, that's that. I can't really think of any other kind of big hurdles. That's about it. It was all pretty much stuff that I've done in the past. Again, it's just like not getting too bogged down on one particular area and just moving on and being like, yep, good enough. What tricks did you use to optimize a large amount of pixel updates? None at all. I don't care about optimization. Not yet, at least. There is a bunch of tricks you can do, which the examples go into, especially this example. And the Noita GDC talk, he goes into it a lot as well. But at the end of the day, yeah, I didn't do anything. I did one example of optimization, but again, that was still too premature, and the work went out the window literally instantly. Do it fast, yes. Which feature you most proud of or enjoy the most making? Yeah. Huh. I would honestly say well, when I first got it to work, the fire, like I just like, I spent so long on just doing some like framework stuff for this. So I was like, this was the moment when I started implementing Fire, where I switched my entire thing over to using Metadesk. So I like switched all the types over into here, because originally I was just hard coding it in C, but I moved the entire thing over to Metadesk, and I spent like a good couple weeks on some like random stuff, and then eventually I got the Fire working just with some very simple rules, and I saw this for the first time, and I was like, that's pretty fucking cool. Even though there's so much more that can be done to make this look so much better. Like, for example, the smoke, you know, it looks dog shit. Like, it could rise so much more slowly. Also, just the fact that like this has structural integrity and it kind of like fades away, like it gets eroded away by the falling sand around it. That was really hype to me. Chunks, even though very unoptimized, but it works. It's surprisingly stable, right? It's just really fucking stable. Aside from the performance, the entire thing is yeah, it's fucking cool. So it was a lot of stuff it was a lot of shit that I just did in the past already, but it's still fun. How's your day going? Good. Blocker you managed to overcome? Yeah, I talked about that before, just kind of moving on from not getting too bogged down in the details. How and why did you decide to prioritize implementing pixel simulation now rather than other aspects of the game? How do you go about ordering your priorities? Yeah. So this was really just a let's do something low level, but also something that'll benefit me long term. So now I have this X and Hilo folder that I can come back to whenever I want to make a game on top of. I can go dive into here and use this as a base for the entire game. So that's pretty cool. So, and I also just wanted to keep doing this because I knew that Telescope still isn't ready to ship. It's getting this close in about, I don't know, a couple of weeks or so. once Ryan has done with the UI, then it'll pretty much be ready to ship. Assuming I just grab a audio library and chuck it in. So I'm really excited for that. I've got a shit ton of stuff coming up for that. So yeah, some really exciting stuff coming in 10 days, 11 days to a week. Yeah. But the reason I prioritize this is because, yeah, it was literally the only thing I could do without going back up into Unity and making games in that. And it's like, the whole reason I got burnt out with using Unity is it's like, I'm using a tool that I'm not going to be using long term. So therefore, I'm spending my time it was almost, I was just getting out a game for the sake of getting out a game instead of it being some kind of skill building long-term experience, right? And I think I can have both. And yeah, anyway, more to come in the future. I'll talk about that in a couple of weeks or so. GPU versus CPU. Yeah, this is all done on the CPU. The only thing the GPU is doing is rendering. We're just pushing a textured quad to the GPU. That's the only thing. I was thinking about parallelizing the entire thing on the GPU, but again, my current mathematical knowledge is too limited for that kind of shit. So maybe in the future, maybe never. We'll see how we go. How are you still sane? I'm still sane because I avoided parallelizing it on the GPU. That's how I'm still sane. And then we got someone talking about parallelizing. Yeah. Nope, not at all. Alrighty, and that's pretty much all the questions. So yeah, thanks for asking these questions. And speaking of Twitter, make sure you don't go follow me on Twitter because it's kind of cringe. Go follow me on Instagram, bro. That's where the real magic happens. raid.gg/insta. I'll leave it in the description. It's just why not? It's so much better over there. I'll leave that in the description. Yeah, and that's pretty much everything. What else did I have to talk about? The build setup. So how this entire thing is actually getting built is you have this thing, build the forge. So this is the forge, and it takes the forge.c and it builds this bad boy. And this looks a little confusing at first, but it's very, very simple. If we just strip this entire thing away to what it's actually doing. So cl, which is the command for msvc, right? And we go cl and you just go the forge.c, right? That's pretty much all it's doing. And then it just builds. Like, it just works, right? And the way I'm actually doing this, so if I hit F1, this entire script will run, build the forge.bat. And it's just a makefile project in Visual Studio. So when you come into Visual Studio, when you make a new project, you just use the makefile project template instead of like console app or any of that, right? And you bring your own kind of like command that you can run. So this just runs build.bat. And for debugging, it literally just runs the exe. And you just provide the right working directory and stuff, and it builds that bad boy. So yeah, very, very simple. This took me a while to figure out and set up, but here you go. Here's the fruits of my labor. Yeah, so there's just a bunch of stuff in here. So we've got, you obviously got to include whatever stuff you need. So yeah, it's just including all the headers and stuff. And then this is actually building the forge.c, and it links out this telescope, which is also pretty cool. So that's just the entire back end of how we're getting this up and running on Windows and all that kind of stuff. And literally, You could even just get this running from scratch on Windows with backend raw windows.c. This is all you need to get up and running on Windows. You can have an entry point right here. I mean, it's not all you need, right? You still need to figure out a bunch of other stuff on top of this, but you could compile this and it would run, and it would give you an entry point to start off with. A lot of cool stuff in there. Yeah, so that's the entire build. That's how it works. That's the structure of the project. That's the solution. That's everything. What else can we dive into here? Not really much. This camera 2D is just a little portable camera thing that I made. Just very simple 2D camera. Yeah, that's pretty much all for this project. Yeah, hope you enjoyed. Hope you got something out of this. If not, then hey, better luck next time, buddy. Yeah, that's the entire thing. Don't really have much more to say, really. Subscribe to the changelogs if you haven't already. I've been kind of just providing some high-level overviews of those bad boys. So you can go to changelog, and these are all these in here. And I've been separating out the X and Hello changelog to its own kind of thing, which I've just been sending out each week, and yeah, it's pretty cool. So you can subscribe to that with email if you haven't already, and yeah, should have some more, a few more videos coming soon. And yeah, I literally have nothing else to say, so I'm just gonna end the video. Hope you have a good day. Peace.